Out in space, where astronauts depend on machines and equipment, one very important factor also gives them their characteristic look: the spacesuit. But have you ever wondered what it takes to craft those incredible suits? These suits may look simple on the outside, but there are thousands of components making them up, and each one costs a lot more than any expensive ensemble you have ever heard of. Now, NASA has decided it is time to retire the old ones and make new and improved spacesuits for future space missions. So, if you want to know how these high-tech suits work, how much they cost, and why they are making new ones, then stick around to the end of the video. We know space isn't just a vacuum. It's a pretty harsh place for us humans with delicate skins and body physiology. So, if we were to just step out into space without a special suit, it would be disastrous. First, there's no air in space, so this will lead to unconsciousness in about 15 seconds. The lack of atmospheric pressure will make our body fluids boil, resulting in rapid swelling and tissue damage. There is also a high chance of getting hit by micrometeoroids or space dust, which are tiny space debris and particles floating at high speeds in space. And since there's no air or other substances to conduct or distribute heat like on Earth, when our bodies are exposed to the sun, it absorbs way too much radiation. This lack of atmosphere also means drastic temperature variations, and astronauts and spacecraft, when not in direct sunlight, can experience temperatures reaching hundreds of degrees below freezing. So, to tackle all of these situations, astronauts live in spaceships where Earth-like conditions are maintained. And when they need to step out of the craft to repair, install, or fix equipment like satellites, conduct experiments, or, like in the case of the moon missions, walk on the moon, that's where specially designed spacesuits come into play. And mind you, these aren't your average clothing. They are ultra high-tech space equipment, having the ability to sustain human life in space just like a space station does. It's a one-person spacecraft. Given its sophistication and importance, they are formally called Extravehicular Mobility Units, or EMUs. An EMU has all the vital things that a human astronaut would need outside of the space station, which is why an average EMU is expensive. They have to be made to perfection, and specialized features, precision engineering, rigorous testing, and advanced materials contribute to their high cost. How much, you ask? Well, it's hard to put an exact price tag because NASA has been reusing the 18 spacesuits, which were actually designed in the 70s for the Space Shuttle program. At that time, a spacesuit was reported to have cost $15 to $22 million. Today, that would be about $150 million. Due to lack of funds, NASA has been carefully repairing the EMUs and redesigning some parts. But how long can they last, right? Those spacesuits were originally made to last 15 years, but it has been more than 40 years of being in use, and now they are well above their retirement age. Plus, there hasn't been any new addition of a new spacesuit, and NASA is now running out of mission-ready suits in working condition. Since 2009, NASA has invested $200 million in new suit development, unveiling the X-EMU prototype in 2019 for its upcoming Artemis program. But it's far from having a whole fleet ready to be worn by astronauts on space missions. Actually, NASA plans to return humans to the moon this decade with the Artemis mission, and plans to land the first woman and first man of color on the lunar surface. The plan is to establish a long-term presence in the form of Artemis Base Camp and explore the moon like never before. This extensive mission is going to need better and state-of-the-art spacesuits and help NASA prepare for future manned missions to Mars. So, what exactly are spacesuits made of, and why are they so expensive? Before we answer that, please press the like button to help us reach more curious people like you. And don't forget to subscribe to our channel for more informative content. Thank you. Now let's continue. A spacesuit is a complex ensemble with various essential components. The prominent white part we are all familiar with is the Pressure Garment System, or PGS. It's made of segments that cover the astronaut's chests, arms, and legs and connect to the gloves. The gloves are also the most expensive part of the entire suit because they need to have physical flexibility to help perform intricate maintenance tasks. Inside, they have complex pulleys and strings to keep them together. On the outside, they have thermal insulation and heat radiators to keep the astronauts' hands warm. The blue fingertips are made of silicone rubber to provide sensitivity. The helmet safeguards the head, featuring a visor for eye protection against harsh sunlight. Some suit sections have multiple layers, each serving distinct purposes, such as retaining oxygen and shielding from space dust. Did you know the space dust could be floating as fast as a bullet? That's right, folks. We are talking speeds as high as 18,000 miles an hour. This is why the spacesuit has to be strong enough so nothing can puncture or penetrate it and cause an injury. Beneath the spacesuit, astronauts wear a cooling garment that envelops their body, excluding their head, hands, and feet. This tight-fitting and stretchy garment has 300 feet of tubes with chilled water flowing in them, and this helps maintain the astronaut's body temperature. The backpack, known as the Portable Life Support System, or PLSS, situated on the suit's back, is a pivotal component. It stores oxygen for breathing, eliminates exhaled carbon dioxide, and supplies power to the suit. A fan ensures the circulation of oxygen, while a water tank holds cooling water. And if in case an astronaut floats away unintentionally, there is a tool called SAFER, which is equipped with small thruster jets. This serves as a safety measure, allowing astronauts to navigate back to the space station safely. But today, NASA representatives say that they are facing issues where they just can't get some parts of the suits, and some of the vendors that made those components don't even exist anymore. So, it's time to build new suits from scratch to take advantage of all the new technologies that are available now and weren't back in the 70s. Last June, NASA chose Axiom and Collins Aerospace to craft new spacesuits for the Moon and the International Space Station. These contracts, potentially valued at up to $3.5 billion until 2034, were exclusively awarded to Axiom and Collins, as they were the only companies that submitted complete bids for the project. The spacesuits developed by Axiom will be utilized during the Artemis 3 mission, NASA's upcoming lunar landing scheduled for 2025. Despite NASA astronauts using these suits, Axiom will retain ownership. Approximately half of the suit's design is based on the XEMU, incorporating features such as boost, helmet bubble, and upper torso. Notably, the new suits are designed to accommodate a broader range of body types compared to current spacesuits. During a demonstration of the new suits, James Stein, the chief engineer, showcased their lunar capabilities, highlighting flexibility and ease of movement. The suit features a large transparent bubble around the head, offering wide visibility and built-in lighting, crucial for exploring shadowed craters near the lunar South Pole. Additionally, the suit includes a mount for a high-definition camera, and astronauts will enter and exit through a hatch in the back, with a backpack-like device containing the life support system. So now you know how important a spacesuit is for space missions. Sooner or later in the coming future, we will be seeing astronauts wearing a new set when NASA decides to launch the Moon program. Would you like to wear a spacesuit? What do you think it feels like inside? Tell us in the comments. If you like the video, please press the like button and share it with others. Check out our next video about the destruction of the ISS, shown on the screen right now. Thanks for watching, everybody, and see you in the next one.